would just not be practical. And we also looked at practical language engines such as Unity's efforts to adopt C# and recognized that unless there's something that's really dedicated to solving these problems, then it becomes incredibly hard to maintain a third-party integration to a language ecosystem like that. So that, plus just a general desire to clean up some of the foundations of programming, led to the decisions that got us here. And the desire to adopt logic programming features, some of this fancy failures, control flow stuff that we've talked about, and the new iteration primitives. There's a lot of expressive power there. We've only barely scratched the surface of what's possible, and over time that will become more and more apparent. And I think will kind of be a direction that future languages and even existing languages adopt more and more. And we thought it would be good to do that once and cleanly rather than trying to retrofit it over time later.
Hi, so it sounds like the verse VM is either in partial work or not started at all, but will that be as permissively licensed as the rest of the verse language spec? And if verse is a compiled language, is it going to be compiled to a IR form, or is that going to translate into something more where the verse VM is directly interpreting it?
Good question. So we intend to release the verse VM with a permissively licensed open source license that would make it easy for anybody to use it in their products. So that's one thing. As for what it will compile to, we're still in the research phase of deciding to what extent it can be ahead of time compiled versus to what extent it will benefit from more the Java style just-in-time compilation. And simultaneously, we're going to make sure that it has a really fast interpreter for all those cases where native code or JITting just wouldn't have been practical.
Okay. And secondly, on the language lifetime, because you talk about a timeless language or a language that has heavy extension, what is the support for macros or things like quotations and splices in a safe language like, say, Scala, where they have heavy support for language extension to allow for some internal DSLs that allow for some of that extendable functionality that you might want to see in a language like this? Because if you really want it to be code as one, you need support for embedding other types of formatted data.
Yeah, so on the front of macros, Reynolds, the old computer scientists wrote down the Reynolds abstraction theorem, saying basically, if a language has the capability of doing something cool for itself, it had better open up a facility for abstracting over that feature for users, right? So we have expressions, so we'd better have variables so you can abstract over values, and we have formulas, so you'd better be able to write functions to abstract over values, and macros are a way of abstracting over syntax. So we think that's important. We have just kind of a straw man plan for going all the way down the macro rabbit hole in the future with kind of the scheme-inspired hygienic macros. C++ programmers are horrified to hear about macros, but actually there are languages that have done macros in a completely clean way that avoid the pitfalls of weird string splicing operations and accidentally aliasing names. There's a really great methodology for that from other languages. We have a plan for the whole thing, and we're not sure exactly how far we want to go down that path. We want to at least get to the point where users, if you saw like the for loop here in verse, well, that's a special construct we made on arrays, but like the for loop you saw in these slides is actually just using a native macro. There's a syntax for the macro. It's some name, parentheses, some values, squiggly brackets, some expressions. And that's the format for a macro. And so it's already designed to accommodate macros at a fairly fundamental level. We'll definitely expose macros for creating iterator-type constructs and conformers and containers of all sorts. So if we can write a fancy syntax for arrays and you create a cool tree type, you should be able to write a fancy syntax for trees. But we're not sure how far down we'll go. It gets a little bit dicey to pick apart the abstract syntax tree of a language and casing over special cases in a macro. And when you get down into those domain-specific languages, they're just built from ad hoc syntax. You kind of have to ask, is this really a language, or have we just done crazy tricks to stick other languages in the language? So I'm not sure exactly how far we'll go, but we'll definitely go pretty far.
Okay, thank you.
Are there plans to be able to implement blueprint nodes like you can do with C++ with verse?
We've thought about that, but we don't have like a concrete plan of exactly how we would do it, what it would look like.
Okay, cool, thank you.
That's a great idea.
Just one of the things we're thinking through as we're developing all of this is the long-term integration plan for Verse into Unreal Engine and how it coexists with blueprints. Right now everything's layered on top of the blueprint virtual machine, so you could theoretically make these things interop more so than we have. But one possibility is to, as we're building this new higher performance virtual machine, layer both blueprints and Verse on top of that, so blueprints become kind of a visual form of the same language that's Verse, and do more to align those. And we've also considered other visual programming directions along those lines. That's an active research topic that we're going to be experimenting with quite a lot over the course of the next year or two.
Thanks for the talk, really interesting. I like your transactional approach. It reminds me a lot of Closure's implementation, if you've seen that one. One question I had was, you seem to be leaning pretty heavily into kind of pure values and pure functions, and I was wondering if that was aimed towards multi-threaded scalability in the future, because I know Haskell and languages like that have derived a lot of benefit from that kind of being their basis.
So for us, the basis is that we're actually going to make transactions over mutable state fast, hopefully. So the language doesn't quite force you to write pure code the way that you would in Haskell. It invites you to write very traditional object-oriented imperative code. So I don't think that we're viewing the pure features of the language as a performance optimization for transactions, although they certainly could be if you use them that way.
Okay, and a second question, if that's okay. Have you looked at, because you're talking about all of this code sharing for like thousands and millions of users, have you looked at kind of alternative forward-looking ways of kind of storing and sharing that code? Things like what Unison is doing with kind of hashing abstract syntax trees and sharing things that way for providing kind of greater scalability than traditional kind of text-based sharing provides.
Yeah, there are really two ways of doing code sharing as we see it in the metaverse. The traditional way is you want to use a bunch of libraries. Great, well, you copy those into your directories, and now you have a separate copy of the library, and you can modify them however you want, and they never change, and now they're kind of your problem to maintain. That works for some things, but we think the much more common approach to sharing in the metaverse will be different authors deploy their own modules and expose them as public components of the metaverse. Right? You've seen that in Verse there are public and private declarations and variables. Well, in the metaverse, like, we take those things for real. If you release a public module, that means any other programmer in the entire world will be able to access your module by its path. You'll have like a path that might start at Fortnite.com right now and then go through your creator name and then have some directories underneath it. Well, that's your module that you've released publicly. And the intention is that the Verse publishing system has backwards compatibility constraints. If you publish a version of a module that says it adheres to some type signature, it exposes some classes and some variables, then all future versions of that module must be backwards compatible with that public specification you made. You're kind of giving the public a promise that your public interface will not change. And in that way, modules can evolve over time while remaining in place and being addressed in place. And we think that that's a really interesting way to allow the metaverse to evolve, where lots of authors are collaboratively adding lots of different features and capabilities and each accessing their things in place. And especially when you get into shared state. If one person creates a scoreboard that supports lots of different types of games and other users tie into that, you're not creating your own copy of that scoreboard. You're talking to the global scoreboard. Right? So the other idea in the metaverse is that eventually global variables will really be global variables. There's one in the whole world, and everybody could access it if you exposed it that way. Right? So the intention really is to have a programming language framework that writ large. And like what we're shipping right now doesn't implement this concurrency model or this shared data model. We have long-term intentions to move in that direction with the idea that the metaverse to the programmer looks kind of like this massive computer that runs very, very fast because it's a whole data center or many data centers full of computers, but otherwise looks single-threaded because this transactional memory system is sequencing all of your gameplay updates through it as it goes. And everybody's code could potentially interact with anybody else's code, and optimizing your code is really about maintaining data locality. So there's a lot of really, really long-term thinking about all of this that feeds into how these systems, especially modules, will interact.
Interesting, thank you.
Thank you very much for showing. It remains amazing, and like some of the questions have already been answered, but just want to confirm, like if I understanding correctly, it seems like the first to compile to the beta code and be processed by the Blueprint engine, and if it's so, like do we have any data of the comparison with some popular script we are using in area like Python and Lua, and something like you mentioned, like if it run into the trap of the global lock like Python, we are just doing it, we are just been typing it for years, but it sounds like it will be like still a global lock there, right? Like it's the restriction of Blueprint engine or?
So we're running on top of Blueprints right now, but that's not the long-term plan. So the long-term plan, the verse VM that we are building is just going to be multi-threaded from the start, basically.
I see. So
And the key thing that saves us compared to Python is, number one, verse is not nearly as dynamic. It's not like an object is a dictionary. So concurrent updates to the object from multiple threads are not as challenging for us to implement as they would be for a Python implementer. And the other thing that saves us is we have transactions. So because transactional semantics is woven deep into the language, even if updating a language required updating a dictionary, we would just simply do it in a transaction and avoid all of the locking problems that you have in Python. That being said, right now, the performance, I don't actually know off the top of my head how it compares to Python or Lua. It's still early days, so the performance now is not really predictive of what the performance will be.
okay, thanks, very helpful.
Hi, I'm really excited. First question would be, have you given any sort of thought to maybe not functional logic programming, but more functional programming concepts like, you already have the effects system, which is awesome, but have you given more thought into like linear types, dependent types, and I did see earlier in the talk that you just briefly mentioned proofs. So is there any thought into like those more like supercharging the compiler that way with those functional concepts?
Sure, I'll talk about some of our forward-looking thoughts and all of that. First of all, yeah, there's an effect system in verse, and there are a bunch of different effects, and you can combine effects. And when you say what things a function can do, and when you write a function that promises to have no side effects, then the compiler really checks that and gives you an error if you violate the promise you're making. Right, so the effects are actually part of the open world type signature of a function, are enforced by the language. And the effect system enables you to say, well, this is a transacts function. That means this function can read and write from memory. But all of that reading and writing can be done within a transaction because the transaction system under the hood can speculatively run this code and either commit it to the global heap or it can abort it and have no changes made at all. There's different points in the effects lattice where there's pure functions which have no side effects at all. And so you can write pure code like you can in Haskell. And then there's even total functions, functions which are guaranteed to produce a result in finite time given the right amount of memory. There's a lot of thinking and planning there around the type system, which is, well, it's a big topic that could be it could have its developers conference of itself. But we plan to go a very long way with the verse type system in building a type system that is statically verifiable and is more powerful than typical type systems you see in languages today. One aspect of it, which you saw a little bit of already, is dependent types. Instead of templates and as in C++ or generics as in C#, you can just write a function that takes a type as a parameter and returns a class as a result. And a generic function like that, it's just a normal function, and types are just normal values. And the compiler over time, we'll do more and more compile time reasoning about complex sets of value constraints. In C++, you have this idea of context, where you can have a function that can run at compile time. If you give it a constant parameter, it will return a constant result. Well, Versa ultimately we've designed a much more thorough system for taking that idea even further. It extends to type checking, dependent types, and some very interesting other features. I guess I've only just given a little hint of it. I can't really go into a lot more detail there, but there's going to be some very interesting stuff happening. And I guess I should just mention, since you opened the door.
Sorry.
There's a this is a really interesting topic. It's funny, very few practicing programmers know about that, but there's this idea of proofs as programs. That's one of the big topics in type theory, if you have ever taken a type theory class, that if you have a type system that's designed in a very particular way, then what looks like normal types in C++ becomes actually a much more expressive and powerful thing at compile time. A type system that's designed in a very certain particular way can actually express proofs about what can happen in a program as it runs. And for example, you can write a sorting function whose return type is promising to return an array of sorted integers. Like that, you can represent that at the type level, and then a type checker can actually type check when you write the function. You weave in some proof code along with your function declaration. You can actually prove to the compiler that your function actually sorts integers. So if the compiler doesn't beep, then your sort function is guaranteed to be bug-free. That's kind of one of the really interesting topics of advanced computer science. And I think parts of this are on the verge of going into the mainstream. And this is an area that a lot of the Verse research team, we've some of the greatest programming language luminaries in the world have joined EPIC over the last few years, like Leonard Augustin and Saipan Payton-Jones, Ranjit Jala, and some other of the best, most incredible language folks in the world have just collaborated academically on the Verse paper in recent times, like Guy Steele from Scheme and JavaScript and other previous language efforts as a contributor to the Verse paper, putting a lot of thought into how to build a language in a type system that's not just some arbitrary programming language designer's fantasy, but is based on these really solid foundational underpinnings of proofs as programs and of type theory, so that what we're building is not just another arbitrary, funny programming language, but is something that really has a direct relationship to mathematics and logic and proofs in a way that, as I talked about at the start of the talk, if we met up with aliens when we compared our programming languages, I think if the alien civilization is sufficiently advanced, then they'll have actually explored and filled out all of these kinds of language features. You don't find in C++ or Java or C#, but you do find in a lot of research languages. They'll have sorted that out, and hopefully Verse is one of the languages that will contribute to bringing these ideas into the mainstream.
Thank you so much. Hopefully this one is a bit quicker, but I assume right now because it's, you gave me a lot of time.
Let's
so
just, we're a little bit over time, but let's just get another 10 minutes of questions since it looks like there's a lot of questions. I'm sorry, I didn't mean to cut you off. I just wanted to call that audible. Go ahead.
Hi, thanks. I'm wondering, I saw on one of your slides you talked about the idea of a metaverse browser, and I just wanted to understand a little better where you see Verse running. Is it on client devices or on the server or both, and how is that managed? Eventually both.
Yeah, and magically so. So the idea, I think the core idea of what we look at as the metaverse should ultimately be not just a whole bunch of different servers running like the web servers do around the world, which have no relationship to each other, right? The metaverse should have the potential of being one continuous, seamless environment in which everybody participates, and any code and any object anywhere could potentially interact with any other object anywhere else. And to keep performance in check, you just have to optimize code using certain patterns. And in that view of the metaverse, you really want the servers that are contributing to the world simulation, whether they're in one data center now or distributed or decentralized in the future, you want all of the servers to be negotiating a single coherent world state as they go. And that implies all of the game logic running on the servers to produce kind of a definitive world state. But now, of course, that actually sucks for practical gameplay because you have 80 to 100 milliseconds of lag from client to server in a lot of cases. And you really can't tolerate that amount of latency and character movement. And so what everybody's been doing, John Carmack pioneered it with Quake World in 1996. Unreal Engine implemented it in 1998. All game engines have been running a predictor-corrector model where the server is running the definitive version of the world state, but then clients are running some local copies of that in order to predict ahead what the next state of the world will be so that you can hide all local latency and player movement and simulation of vehicles. And the server is correcting that. So sometimes you see some jittering in the objects. Well, that's when the server's, the client's making a prediction and then the server's coming in and correcting it later on. But the way this has been done in Unreal Engine 1 through 5 has been fairly ad hoc. We expose some functions with explicit declaration saying this code runs on the client, this code runs on the server, and you write your code very, very carefully to make sure all of those functions are running in the right place and are negotiating the world state. This is something we really want to automate in the future so that you have one definitive code base, and from the programmer's point of view, the programmer ought to be agnostic on where the code is running, but code that is contributing or receiving player input or other local things ought to be predicted locally on the client side, and then corrected by the server side. And rather than this being done manually by programmers writing specifications, the language runtime ought to handle this automatically. That's the vision. We hope that we can implement this. Not everybody's convinced, but for the right now, for UEF and this current version of it, it's Epic written code running on the client, and then user written code running on the server. And if we want something to be predicted really well on the client side, then Epic, at the moment, has to write that. Because it turns out it takes a lot more rigor to get a scripting language that can be trusted to run on the client side. You have all of the security considerations of like JavaScript in a web browser, plus additional console considerations. So we want to get there, but we're at least a year away, perhaps quite a bit more.
Thank you. Yeah, so I really like everything I've seen. One thing that hasn't really come up in conversations is memory. I assume that verse is garbage collected, given that it runs on Blueprint VM now, et cetera. It's a functional logic programming language. Are there any concerns about space leaks or GC pauses being a performance issue in the future? And have you, no one's mentioned Rust, but I'm going to mention it now. Have you looked at other memory models that are maybe more inspired by a Rust ownership model or something else?
Sure. So in terms of space leaks, even the ownership model wouldn't help you there.
True.
If you allocate too much stuff, that's on you. In terms of GC pauses, that's an engineering problem. And so I think that that's how we're going to approach it rather than moving the burden on the programmer the way that Rust does.
Yeah.
That's right. Right now, there's a garbage collector that will run from time to time, and it might cause hitches. That's the current version of it, but this is a problem we'll be solving more and more over time as we implement the new VM. And the aim of Verse is to just let programmers write as simple code as possible to solve their problem. We don't want programmers to have to worry about memory ownership annotations as they write code. It's just another thing that's not all that critical if the compiler and runtime can solve that problem for you.
Okay, first off, this was really interesting. Really interesting project. Is set a transaction when you're setting a variable?
Set itself is not a transaction. It's just one operation within a larger transaction. The way to think about the transaction scope in Verse is you're always in a transaction until you suspend. So like in the example where you called wait for input, if that thing actually waits for input, that's a transaction commit followed by a new transaction starting after the input comes in. But if you just write a bunch of code that doesn't have any suspensions in it, that's all within a single transaction and completely atomic.
Oh, okay, so that makes sense. So that means that that transaction, all of the state changes within that transaction, when they propagate to all of the other people that are sharing the same state.
Yeah.
Okay.
All or nothing.
Every actor tick basically is its own transaction. So there's no concurrency yet, but in the future, every actor tick could try to run in parallel. And when a bunch of actor ticks don't have any read-write conflicts, as detected dynamically, they could all commit. And when some have conflicts, then some would have to be aborted and retried. And that's the whole idea of transactions. But you know, when you have one actor updated and it talks to another actor and that collides with a third actor, you could have a pretty large chain of events happening all in a single transaction scope.
Okay, thank you. Second question, functions first class, yes?
Yes, mostly.
Okay.
Right now.
All right, thank you very much.
And this is the last question, sorry. Go ahead.
Okay. Hearing about all of this, it sounds really cool, and it reminds me of Unreal Script back in the day, which, if I am remembering and understanding correctly, was ultimately deprecated because it was such a big task to keep it updated and keep it up to date, and there was C++, which had kind of solved a lot of the problems already. So what kind of new problems is Verse trying to solve that isn't already being solved by another language? Like, I have some ideas based on listening, but I just would be interested to hear what you guys consider the new problems that aren't already solved.
You know, when we moved from Unreal Engine 3 to UE4, we made a really hard decision to get rid of Unreal Script. We realized that in order to keep up with the expectations of modern languages, like generic types and all these other features that were popular in C++ and growing into C#, you need a world-class language design and implementation and research team. And we had like one guy, and so that just wasn't a possibility. And so falling back to C++ was kind of the natural thing to do. And it worked just fine for AAA developers, but it was not a great outcome for indie devs who found it just harder than writing in a scripting language. The solution in the Verse era is a language that really advances the state of the art in a number of areas, with logic programming, with this work on transactions, and with other aspects of a programming model that we think is more appropriate for the metaverse. And thanks to Fortnite's success, we were able to assemble a world-class language implementation and design and research team. And we have that here in the halls of Epic, and we have collaborators all throughout academia who are committed to contributing to making this work. So we feel we have everything we need now to make a really successful go of it, and we think this is a good thing to do. It would be very unfortunate if the move to the metaverse left us with a bunch of rather messy, untyped, non-concurrent programming languages as the foundation of it.
And
One more?
oh,
Last guy in line?
I think we have to wrap up now. But we can continue conversations in the lobby or the show floor. Thank you, everybody.
Thanks.